Yeah, so as we discussed yesterday, few of the performance tuning tips like what are the main proactive tuning tasks as a DBA we have to take care. As discussed, like once we build a cluster, we have to follow some standards. Like main important thing is parameters, as your entire cluster will depends on your parameters, right? So parameters plays a major role, especially the memory parameters. Your performance will it depends on your memory parameters. So whenever you initialize the cluster, you take the help of PG tool, and you can PG tune tool, right? So it will give us the necessary parameters as well, you know? So you can just add those parameters, and later you configure your backups, you configure your logging, editing, and if you have any PCI system, you can also configure your security if you want. And then later you also need to configure your tuning packs as well, right? So few of the performance tuning uh, packages you need to install as a part of your monitoring. If you want similarly like AWR kind of report, okay, we have PG profile. So those things and all we'll see. So before we go that, we can just see few of the, first we can discuss about the PG bench. What is a PG bench, and what is the use of this PG bench? And then we can discuss few of the parameters, okay, how it will behave based on different values, especially memory parameters. And then we can also discuss about the analyze command, what is the importance of analyze, and explain plan, how we can see the execution plan. And then followed by we will also see how we can enable AWR kind of report, those stuff. Okay, so first let's start about the PG bench. So we have a utility called PG bench, which is a part of our binaries. Okay, so this utility or this tool is mainly for to estimate your database capacity, like and an average how much uh, the queries is generating, your average latency, and how many transactions per second. And for these queries, how many number of threads it is using. For example, I have 100 sessions connecting at a time in a database per second, or maybe per minute. We can expect 100 sessions is connecting, and 100 sessions is doing some 100 transactions, or maybe 10 sessions is doing some 100 transactions. Okay, how the average latency looks like, and how the transaction per second looks like. Okay, we can able to identify with the help of PG bench. This is some kind of benchmark test, or maybe we can assume this is something load test. Okay, so we can do the load test, like this many sessions connected and this many transactions is happening, how the database is behaving. And you can just change the values, and you can do the load test or benchmark test. Okay, so this is the utility which comes as a part of your binaries. So we can just use --help to see the list of options what we have. So if you see, first we need to initialize this PG bench. For example, you have a database and you want to initialize this PG bench on the database. You can just initialize or invoke this PG bench. So when you initialize, what happens? It creates 4 tables in our database, like PG account, PG bench account, and some 4 tables it will create. And by default, it generates 16 MB of data into these 4 tables. Okay, it will populate the data into 4 tables. That is just a dummy data, just to do a benchmark test. Okay, so these benchmark test is not only doable for those tables, you can also do your application tables as well. Okay, so we will also see how we can do for the application tables, or you have to do only for your selected queries. Okay, this PG bench, even you can do that if you want to do for any select queries. If you run the select queries with this many threads, this many sessions, this many transactions, how this is behaving. So those kind of stuff we can do with the PG bench. So first we need to initialize this PG bench, and then we have some options, like parallel option we have. Okay. So we have select statement. Okay, this is the benchmark options. Okay, we can use. So this is the main important client. Okay, how many number of concurrent connections is connecting to the database? If you not mention any of this option, by default it will connect with only one session. Okay, so for example, if you want to try with 100 sessions how this is behaving, you can try. and number of parallel threads we can mention, and we can also mention the latency, and the main important thing is transactions, okay, and the scale factor. These options we can use different options, and we'll try how this is behaving. Okay, so for example, first let me try to check what are the databases I have. Okay, probably let me create a new database called PG bench test. Okay, this is my database name, and now I want to initialize the PG bench into this database. Okay, for this what I will do, PG bench hyphen I is for initialize, right? So we have seen hyphen I is for initializing this. We can just use hyphen initialize or small I, okay, to initialize. And I want to initialize with some scale factor 25, okay? And for which database I want to initialize? This database. So internally what it is doing, it is trying to create 4 tables: PG bench account, PG bench branches, history, and tellers. Okay, and it is trying to populate some.
Did you share the screen?
Oh, you are not able to see my screen?
I'm not able to, but
we're able to see. We're able to see.
Yeah,
okay.
I can see so.
Okay, I have some issue. No issues. Yeah.
Oh, okay. Yeah. So it is populated this much data and it has created a primary key, and it also does the vacuuming as well. Okay. So PG bench, what it does internally, it has some set of PL SQL program. It just executes that PL SQL program. In that PL SQL program, it creates these 4 tables and it populates some data. This is just a dummy data, just to see how your database is behaving. Okay. Not only for these tables, you can also see for other tables like your application tables as well. Okay, we'll see that also how we can do that. Now I have just initialized this PG bench. If you initialize, it will just populate some tables and data into it. Now I want to do some benchmark test. For example, I'm connecting some 100 sessions into this database, or maybe 10 sessions, and I'm doing some 100 transactions or 10 transactions, how it is behaving, how we can do that. So PG bench. So we have option -C for client, how many number of sessions. For example, I'm connecting with 10 sessions, and we also have parallel option, right? So for example, I'm connecting with 2 threads, okay, parallel connections, and I'm trying to execute some 10 transactions. So for transactions, we have -T, okay? So 10 transactions at a time on this database. Okay. So here what I'm trying to do is I'm trying to do a benchmark test with the help of this utility, and here I'm connecting 10 sessions into this database with parallel 2 options, and each connection will do 10 transactions, which means 10 connections will do 100 transactions, right? So let's see what it. So internally, if you see, it is doing some update, insert, select, delete. So this all it is doing with the script actually internally. So it is having a PL SQL block or PG SQL block. It is just trying to do inserts, updates, and some select statements, just some random transactions. Okay, just to see how the latency looks like. If you see, this is the maximum number of connections which we have, and scale factor is 25 default, and the number of connections is 10, and we use 2 threads, right? And if you see, the total number of transactions actually processed is 100, because we have did 10 transactions. Each client will take 10 transactions, and it operates 100 transactions. It has performed successfully, which means it does inserts, update, deletes, like this, something 100 transactions. Okay. In this case, how the latency looks like. So currently my average latency is 52.93 milliseconds, and this is the transactions per second. So currently I have 188 transactions per second in this case. Now we can also do this load test. For example, if I want to change something like this, I want to connect 100 clients with 100 transactions. So we'll see how the average latency look like. This is something called load test. Okay. So we'll see what happens. Since it has to perform 1000 transactions, it may take just a minute to complete. So once you do different kind of tests, you can just make a note of that latency values, and so that it's easy for us. So the latency value and the main is transaction per second. Okay, that is important for us. So we can just make a value, and with the different parameters, we can just verify how the database is behaving with this kind of load. Okay, so that it's easy for, sometimes what happens, your application team will ask you to do a load test for this many sessions, what is the latency, average latency it is looking for, and how is the transaction per second it is having. Okay, so like this you can do a different testings with the help of this PG bench. And for example, if you don't want to do updates, inserts, everything, you want to do only the load test for select statements. So for select statements, you have -s option. So what it does, it only do a select statement. Okay, for example, I want for 10 clients and 10 transactions. I mean 10 select statements. It does internally. Okay. So -s is only for select statement. If you want to do for select, so it does only select statements. If you say it will not do any insert, update, and all these transactions. And for select statements, this is how the average and average latency and transaction per second looks like. Okay. And now, for example, this test is for internally whatever the PG bench created, right? 4 tables it is doing, but I don't want to do for those 4 tables. I want to do for my customized tables based on the development team requirement, or maybe something like this. Okay, they will give a select statement to you. Okay, they want you to check for this select statement how the average latency looks like. Okay, so for this, probably what I can do, I can just try to create a small table. Okay, I have a table. Now they want me to do some, for example, I will just try to create a script. Some kind of data I'm trying to insert. Okay, I also want to do for select start from test. We'll also do for select start from test, order by one, something like this. Okay, some set of queries they have given in one of the script. Okay, you can just give that kind of comments. Okay, if they don't want to do for insert statements, if they give for a big join operation complex query, you can just add that query here. And for this query, if you want to do a test, benchmark test, so how this is behaving. Okay, so same comment. So what I will do, I want to test this to do for 10 connections. Okay, and I want to pass this script for this. Yes. What is the script name which I have given here? Insert.sh, right? So any name, whatever name you want to do, I can just pass the script to this PG bench, and whatever the statements it has, this 10 connections will take, and it will execute this into 10 times. Okay, we'll see what it does. So it is trying to do insert everything, and this is the average latency it looks like, and this is the transaction per second for the given queries. Okay, and if you go and see, so it does how many times instead of this? 300 times, right? So, so with different values, you can just try to compare, and it will do this average kind of test. Okay, majorly this you can do for for your application, whatever the scripts which they have given. Okay, so you can pass the script to this PG bench actually. Okay, and you can do this different testings as well. So this PG bench is not only for doing the load test for your tables and something. So with the help of PG bench, you can also decide few of the parameter values as well. So for example, let's take shade buffers. Okay? So usually shade buffers, when you take the help of PG tune, it will allocate 25% of your RAM. Okay. So currently mine is 128 MB of my shade buffers. Okay, shade buffers is very important parameter that we need to consider, right? Because all your recently accessed data will be stored in the shade buffers. Now I want to with 256 MB of my memory, I want to check how with the help of PG bench how the transaction per second looks like. Okay, for example, let's take the same thing. I want to do 100 transactions, okay, with the 10 clients. And I not only want to do select statements, I want to do everything. Okay, we will just see how the transactions looks like. Okay, let me take the other session. You are able to see the other session also, right?
Yeah.
Yeah. So I'm just making a file just to make a note how the value, So currently I have shade buffers as 128 MB. Okay, for 128 MB, what is my latency average looks like and how my transaction per second looks like? This is the one. Okay, for 128 MB. Now what I will do, I'll try to change this value, alter system set shade buffers to maybe I will go with 256 MB. Okay, since this is a static parameter, I need my cluster to be bounced. So let me restart my cluster. Now let me check my shade buffers. So currently it is 256. For 256 MB, let's see how the latency looks like. Okay, so for 256 MB, this is the average 256 MB. This is how it looks like. Okay, for 128 MB, we have latency value 60. And this is important we need to see. So transaction per second. Since the memory is big, so transaction per second has reduced, so which is good. Okay. Now let's keep this aside. Let me do one more thing. Let me go and change to 500 MB. And let me restart the cluster. And let me do the test again for 500 MB. We'll see how it looks like. So this is a value for 500 MB. Next, let me go and do for 1 GB. So for 1 GB, this is the transaction per second. So with these values, basically how we can decide which is the good, so good value actually. So based on this parameters. So if you see averagely, if you look latency value and transaction per second. So even though if I change to 1 GB, I don't see much difference, right? In terms of, so latency. So but based on these values, actually we can able to decide and an average, what is the best value for your current workloads. Okay, if you connect this many connections and this many transactions if you are doing. So basically we need to have an idea based on your application type, how many sessions and how many transactions per second it is trying to connect to the database, probably 100 or 50 or something. So based on that value only, we can able to decide which value is the better. And if you see, even though if you see for 128 MB and 1 GB, you don't see much difference, right? So which means if you increase much value to shade buffers doesn't help you in terms of performance, right? If your transactions is connecting this many things, this many connections and this many transactions it is doing per second, so you don't see much difference, right? So which means we need to understand that if we increase the shade buffer to a bigger value will not help you for higher performance. Okay, this is entirely depends on your disk speed and your resources. Okay, basically based on this PG bench also you can able to decide this parameter, memory parameters as well. Okay, so this thing we need to keep in mind. Now now let's see one more parameter called work memory. So work underscore mem is also very important parameter. So work underscore memory will be allocated for each session, right? So whenever any session connects, okay, your postmaster will authenticate the session, and then for that dedicated session you have a virtual memory, okay, which is your work memory. So it will allocate the work memory for this particular session, which is 4 MB. 4 MB is the default value. Okay. So this value we have to, increase based on the PG tune parameter, right? So based on PG tune tool, we are going to increase this value. So we'll see some different tests how this is behaving. So basically what will happen in the work memory, it will do your sorting and merging, right? So whatever the transaction which you connected, whenever you are doing any sorting and merging operations, so your work memory will be used. Okay. So for example, I'm already in, let me see if I have the big table. A very small thing I have in source DB. Okay. So source DB, I have a employee table. Let's see how many records it has. Okay, I have an employees table. Almost I have 3 billion records in this table. Okay. Now let me do some complex select query on this table so that we'll understand how this work memory works. So currently my work memory is 4 MB, right? So I want to fetch some data with some sorting and merging operation. For example, I want select. Let me see what columns I have in this table. Select ID, comma, email, mobile number. Okay, from employees. Maybe I can just do order by maybe I will just do order by first name. Okay, and I also want the first name to be in uppercase, so I can just use upper function. Okay, and I also want only some first 100 rows, okay, which is like your equivalent to your row ID. Okay, so this is how I am trying to fetch the query. So this is something complex query. So to get output, you will get some time. So basically, instead of directly running this query, I will just take the execution plan to understand better. So explain and analyze. So don't worry about explain and analyze. I will explain what is the explain and analyze basically. So to take the execution plan, we can use the explain command. It will give the execution plan of this query. Okay, and analyze is, if you pass the analyze to this execution plan, it actually executes this query and then it will generate the explain execution plan. If you remove this analyze, it will only give the execution plan for this query. So I want the query to be executed and I want execution plan for this. So I can just use this. So we'll see how the execution plan looks like for this particular query. If you see here, work plans, so workers. So by default, optimizer allocated 2 worker process for this query. So basically this worker process will be allocated by optimizer based on the complexity of your query. So for my query, it has allocated this many parallel workers. Okay. And if you see here, sort method, this is important. Sort method, memory. So if you see the data which you are trying to fetch is able to fit in the work memory. So work memory size is 4 MB. So, but you are trying to fetch 48 KB. So 48 KB is able to, do transactions. I mean, sorting and merging into this 4 MB, right? 4 MB of your data. So for example, I will go with a bigger, something like this. Okay, I want to fetch so many records, still like 10,000 records. We'll see how much. Okay, it is using this much KB. Okay, still it is, sorting in the memory itself. So which is, sufficient. For example, if you are trying to fetch the data more than 4 MB, then what happens? It will hit the disk, which means it costs more IOs. Maybe what I will do, I will try to, set at the session level, work underscore mem to 64 KB, for example.
After system, it's not required.
No, for session level, we can just directly give with the set command. We probably set work mem to equal to should be equal to only what it is telling. This parameter is B. Oh, okay. So here it's asking to give in the small letters. Okay, so K should be small. I don't know why remaining all is capital letters. I don't know why they have designed something like this. Okay, so now I have set the work map to 64 KB. Okay, from 4 MB to 64 KB. Now since this is, I think this is dynamic parameter, it can be changed on the fly. So for this, I need to just reload the configuration, right? So I'm just trying to reload on. Now when I see show work underscore mem, okay, it is 64 KB for this particular session. Now let me try to execute the same execution plan. We'll see how this is behaving. If you see disk, it is hitting the disk, right? Because it is trying to process this many KB, but you have only 64 KB. And if you observe the time, execution time, if you just observe, if you are hitting memory, how is the execution time it is happening here? This hitting memory here, and this is 4,732 milliseconds. But here, if you see, 22,000 milliseconds, which is almost or maybe 8 times greater than this, right? So always when you do a select statement or whenever you're doing sorting and merging, your work mem plays a major role. Okay, so maybe what you have to do is, on an average, you can allocate based on your so based on your resources, based on your memory, you can allocate on an average this work memory maybe to 1 GB or 2 GB. But later, maybe when you are trying to select this much of maybe you are doing whenever you are trying to do any bad jobs and you are trying to fetch this many data, maybe 25 GB or 50 GB of data you are trying to pull from the database. In that case, you can just set at the session level. Okay, in the same batch job, you can just set at the session level and you can just do this batch job so that it will only change to that specific session. Okay, So it's always good to change at the session level, this work memory. And an average you can set to 1 or 2 GB for normal workloads, okay, at the cluster level. But later, based on your batch jobs or based on your complex of your query, you can change this value to at the session level. You can increase this memory, okay, with a set command, something like this. Now maybe I want to a bigger value. For example, instead of KB, I will just go with MB. I can just set at the session level and I can just fetch this data. Okay, so this data is something, almost this much KB it is trying to fetch. Okay, if you just increase to MBs, it will be fast because this will be, processed in the memory itself. If you hit the disk, definitely your execution time will be increased, right? Because the data it is trying to sort, it is not able to fit in the work memory. Definitely it will hit the disk and it will impact your performance. So that is the reason whenever you are trying to do a complex queries, is always you can set session level for that complex query to a bigger value. If you think that the current cluster value which you allocated is not sufficient, you can set at the session level and you can do this operation. Okay, and with the execution plan, you can check whether this is hitting the memory or disk with the sort method. Okay. And even the cost also will increase if it is hitting the disk. You see the cost, this is the cost, right? So, and this is the actual total cost. Okay, this cost is for this sort operation, so it will increase definitely. So this is how you can manage this work memory. And you also have the other parameter called work maintenance work memory. This is also very important parameter. So this maintenance work memory, usually in what scenarios this maintenance work memory will be used? Okay, whenever you do any vacuuming operation or whenever you do re-indexing operation or index rebuild kind of operations, clustering operation. So in this situation, this maintenance work memory will be used basically. Okay, so default is 64 MB, and even this you can increase based on your workloads. Okay, to a average value you can set at the cluster level, and even this value also you can set at the session level based on your complex operation. For example, you have a very big table, 1 terabyte, and you are doing a vacuuming operation on that table. Okay, it requires uh, good amount of maintenance work memory, which is 64 MB is not sufficient in that case, right? So you can set at the session level, maybe some 10 GB or something if you have memory, and then you can do the operation like vacuuming or doing indexing or something like this. Okay, for example, let me take any table. Maybe I can just take the same table. Yeah, this many records I have, right? So let me see if this table having any index already. Yeah, I think already index is present on the ID column, right? So probably let me drop this index. Okay. Okay, what I will do? Maybe I will try to create an index on this column. Actually, this column is not a good candidate for creating index, right? This is a good candidate, but still, just for testing purpose, I'm just creating the index on this particular column. Okay. So index operation will also use reindexing or index clustering, vacuuming, whatever operations will be used by a maintenance work memory, right? So maintenance work memory default is 64 MB. Now what I will try to do is, let me do a timing so that it will be easy for us to understand how much time it is taking to create an index or doing vacuuming operation, whatever it may be. Now I have this many records, 3 billion records. On the top of 3 billion records table, I'm trying to create an index, okay, for any column. Currently 64 MB. What I will try to do, I will just try to change this to 1 MB. You see how it is behaving. To 1 MB. Okay. After changing this, I'm trying to create an index. we can just give any index name. So EMP underscore IDX or something, whatever the name, on employees table. On which column I'm trying to do? Already have ID on an ID column. I have index. I'm trying to create on this. Actually, this is not a good candidate to create, but still for testing purpose, I'm trying to create an index on this column. Okay. We'll see how much time it is taking to create with 1 MB of maintenance work memory. And it has 3 billion records in this table, right? So we'll see how much time it is taking. Okay, this many milliseconds it has taken, 24,567 milliseconds it has taken for creating an index with maintenance work memory 1 MB of table size. To fetch with the DT plus 313 MB of table size with maintenance work memory 1 MB. It took this many milliseconds. Okay. Now what I will try to do, I will try to change this to maybe some bigger value, which is 10 MB. Now let me create the index again. Okay, before that I have to drop it. Let me drop the index and create the same index. Okay, I'm trying to create the same index again with 10 MB of size. Okay, so it took 23,000. Previously it took how much? 24. Okay, if you increase the memory, definitely your maintenance of this, creation of index will also increase, right? So let me do it to 64 MB, which is normal default value. Okay, and let me drop the index and let me create it again. So which it took almost same with 10 MB and 64 MB is the same. Okay, so this memory parameter value also plays a major role when you are doing maintenance activities like rebuilding the index or creating the index, or when you are doing the clustering operation. So what is the clustering operation? We'll see in just next topic. Okay, and when you do a vacuuming operation, so this maintenance work memory is very, very important parameter that we need to consider when you are doing on big table. Okay, when you are doing this kind of operations on a bigger table, you definitely need to consider this parameter. Otherwise it will run ever. Okay, so this is one of the main important parameters that we need to consider. Okay, these are the main important memory parameters that we need to consider in terms of performance based on your load. Okay, you have to decide it. So before you hand over to application team, whenever you build a new cluster, you have to check these memory parameters, and then you have to hand over. Okay, you have to define your own standards and you have to hand over. Again, when application team is running any bad jobs or something, we have to suggest them to set the work mem parameter based on the data which they are trying to fetch. Okay, at the session level, we can help guide them to set this parameter. Okay. Now let's discuss about the analyze command. So we have analyze command. So analyze command is used to gather the stats, right? So it collects the statistics of your table or database, whatever you have collected. So usually what happens, your auto vacuum process will take care of doing analyze whenever your table is changes 10% of data in your table. Automatically auto analyze process will kick off and your table will be, collected the stats so that it has the good execution plan. Optimizer will create a good execution plan based on the statistics only, right? If you have old stats, then it will go for bad plan. So that's why analyze is very important. And most of the cases, your auto vacuum process will take care of doing auto analyze when you do 10% of changes to the table. But few scenarios, if your table is very busy table, for example, you have accounts table in banking. Okay, account table is very, very busy table because per second, you will have so many transactions happening, right? So at that moment, auto vacuum process will skip to do vacuuming as well as analyze. So in that case, you have the old stats. Okay, for that kind of busy tables, we can gather the stats manually. Okay, in that case. Okay, we know how to check when was the last stats happen. I mean, when was the last analyze happen and when was the last vacuuming operation happened with the help of so we have a view called PG stats all table, right? So with the help of that, we can able to see. Okay, so for time being, let's do the same example for this table employee. What I will try to do, I will try to, disable the auto vacuum process. I mean, so vacuuming process for this table. Okay, so let me do that. Alter table name, set let me see exactly what is that to disable this auto vacuum for temporarily. Just to understand better, probably I want to disable it. Okay, so let me see if I have, okay, auto vacuum enabled. Okay, so by default auto vacuum will be enabled, right, when you initialize the cluster. So for temporary for this table, I'm going to disable the auto vacuum to understand better how my analyze, if I have the old stats, how my system is behaving. So I just want this to be, check. So for this purpose, I'm just trying to disable the auto vacuum for now. Let me stop the timing. I don't want timing. Timing is off. Now what happens? So I have a view called PG stat all tables, right? So with the help of this view, I can able to identify how many live tuples I have and how many dead tuples I have, and when was the last vacuum happened and when was the last analyze happened. So this is my table, right? So for this table, I'm trying to check. So for now, I have disabled auto vacuum and there is no vacuum process happened and last analyze also happened. And I have this many live tuples and there is no dead tuples right now, right? Now what I'm trying to do is I'm trying to delete some records. Some 10,000 records I have deleted, okay? Maybe this many records. Now, how many records I should have in my, this many dead tuples and this many live tuples I have, right? Now, I will try to, explain, analyze, same command, explain, analyze what we did previously, right? So same command we can run to see how, yeah, this one. I want to check the execution plan for this query. So we also have PG class. From the PG class view, we can also identify how many tuples I have and how many pages it has. Those things actually, if you see here, the rows which it is trying to process is, wrong rows, right? So actually it is trying, currently how many records I have? This many records I have. But since it does not have the latest stats, it is picking the wrong rows, right? So it is, able to identify some different values, which is not correct values, right? So this is how the stats, if you don't have the latest stats, then definitely this gonna fail. I mean, this is gonna give the bad plan, not fail. Okay. So I also have PG class. Okay, PG class also I can able to identify. Let me see what is the exact column. Relation tuples, and if I want to see how many pages this table has, for example, relation pages, PG underscore class, where rel name equal to employee. Okay. Rel tuples is, let me convert into integer. Okay. If you see still this PG class view has tuples has 3 billion, but currently how many records I have? So it is having the wrong values, right? Because of the stats. Okay, it does not have the latest stats actually. So that is the reason it is giving the wrong values. So if you don't have the latest stats, then your execution plan will be not the good plan, right? So that is the reason we should not disable this auto vacuum at any cost. So auto vacuum should always keep on running, but even if you have auto vacuum enabled, but few times what happens, your table is busy, then it will try to skip. Okay. So for this purpose, we have to do analyze. So analyze is very important for having the latest stats. Okay. Now I have this analyze and I have the correct value right now. Okay. So this is how analyze will help you to have the latest stats, and otherwise it will have the old values, and your execution optimizer will think this many records it has and your plan will change. So you should not disable this auto vacuum at any cost. Still you have to gather these stats for a very busy tables in out of office hours. So it's good to have in any cron job or some in any script. Okay, you can just have this analyze for a busy table and you can have the latest stats. If your stats is out of sync, okay, if your table is busy, anyway your auto vacuum process will skip. And if you can just check the last analyze timings, and based on that you can add in the cron jobs for a busy tables. Okay. Now, so one more important thing is for index. For index, actually, we have reindex operation. Okay, so reindex command is very useful for in Postgres for a DBS. Actually, in Oracle, for doing a rebuild, actually what you do, you try to pull all the details of the indexes and you drop the index and you recreate it, right? If you want to do in offline, but in online you can just do with string option, right? In online you can also do a rebuild. So in Postgres you don't need to take any of the details. If you want to rebuild, drop and create, you have a utility called reindex db, okay, which will help you to rebuild the index. If you want to rebuild for all the tables, you can just use all the indexes will be rebuilt with the -a option. And if you want to do a rebuild for a specific database, you can just use -d option to to rebuild the index on the specific database. And you can also do for a specific schema. You can do for system catalog tables as well. Even system catalog tables will also get fragmented few times, right? So you can also do this for system tables. And you can also do a specific table. You can also do a specific table space. You have multiple options. For example, I want to do for all the tables, or maybe for all the schemas, or I want to do for a specific database. For example, I want to do for this database. Okay, I would have done the verbose option so that it will show you what it is doing internally. So next time maybe we can just use this -v option. We'll see how it does. Let me do the same thing again. So if you see, it is trying to rebuild the indexes, whatever the indexes have present in that database, everything, all the indexes will be rebuilt. Okay. So for employee stock table, okay, for department table, and EMP table, all that, whatever the tables I have in this database, along with your system tables, it will also do the rebuild for all the tables. Okay, if you see, for PG subscription relation, for PG class, for all the, for even information scheme also it does rebuild. Okay, it do along with your application tables, it also do for system tables. Okay, if you want to do for a specific table, you can just use -t and the table name you can do. And if you want to do a specific schema, you can just use -n and the schema name. Something like this you can do. So this is one of the good utility which they provided in Postgres for doing the rebuild operation of your indexes. You can do in out of office hours. So it will be better for better fragmentation and better performance. Okay. And we have something called clustering, right? So I was talking about the clustering. So clustering is something that will help you to let me do one thing.
So Suresh, I have a question. So on what basis we need to do this reindexing? I mean, is there any?
Yeah, actually we have a extension called, let me see. So based on the fragmentation, okay, we can able to identify how much fragmentation happened in that index. Okay, based on, we have some extension called, let me check what exactly, I did not able to remember that extension.
Okay.
PG stat extensions. Okay. So based on that extension, if you install that extension, we could able to identify PG stat tuples. I think this is the one. Okay, let me try to create this extension. So for example, I have this table, right? EM employees. So this, for example, this is my index. Okay. I want to check for this index how much fragmentation I have. So with the help of this extension, we can able to identify. Let's see what. Yeah, this one, PG stat index. So for example, select start from PG stat index. I want to know for this particular index. What is my index name? This is my index name. So it will give all the details, like what is the, tree level currently, what is the index size. It also give the leaf fragmentation. So currently, since we do the rebuild, right, I don't see any fragmentation here. So previously we would have checked the fragmentation. So if you found the fragmentation, like a bigger value, okay, based on the size, you can able to do a rebuild of your index. Okay. So with the help of this extension, PG stat tuples, we could able to identify the fragmentation of the index, or even you can able to identify for tables as well. Okay. So you have stat tuple as well. So this is for normal tables. You can able to identify the fragmentation of this as well. And you also have a other select query, which is I have provided in the lab manual in vacuuming to check the bloat tables, right? how much waste spaces in the table. So based on that also, you can able to segregate the indexes and tables, and you can do the rebuild operation, and you can do full vacuuming operation as well for if you find the bloat tables. Yeah. So something like this you can identify and you can do the rebuild operation. You can just segregate all the indexes if you have more than 100 GP indexes in the database. So you can just segregate that in one go. Maybe you can do weekly once or weekly twice. Okay, in the cron job you can do the rebuild operation for that kind of busy big tables, and you can segregate small indexes below 100 GP whatever. You can do monthly once because that is not a big deal. Very small indexes less than 100 GP. For big busy tables only, you have to consider the fragmentation. You have to do the rebuild operation, maybe monthly once or monthly twice based on your requirement. Okay, so something like this you can identify. Yeah, next what we can do, we have something called clustering, right? So clustering is something which will help you to, order your table data in proper order in the physical layer itself. So basically what I have, for example, so let's start from employee, or maybe to understand better, I can try to create two small tables. Because of these big tables, we cannot understand how this is, for example, I have, okay, so create table test, okay, and I will create two columns, ID int and name varchar. Okay, now I will try to insert the data into this table, something like this, insert into test values. Maybe this value I will try to give something like this, 3. Something, okay, this value is missed. And then I can go for one A. I can go for 2B. Okay, something like this. I have some data like this. Okay. So now if you want to fetch the data in proper order based on this ID value, what you can do, you can just create an index. So when you create an index on this particular column, index will store all your values in proper order, right? And and if you want to store the data itself in proper order in the table itself at the physical layer, you have something called clustering. So you can do clustering of clustering on this table based on the index which you have created, so that your data will be physically in proper order. Now, if I want to fetch the data in proper order, what I have to do? I have to give order by class, right? Which is complex operation. For example, order by 1. It will give in proper ascending order, right? The data 1, 2, 3, and so on. Now I want to store my entire data in this particular format in physical storage itself directly. So we have something called clustering. So before this, what I'm trying to do, I'm trying to create an index test underscore IDX on test tables on this column. I created an index on this particular column, right? Now, I will try to do a clustering. Okay. Just a second, I'm getting a call. Yeah, sorry about this. So I have an index on this particular column. Based on this index, I can just use the clustering operation. Okay, so for example, let me take the help command. Okay, so how the clustering will happen? Cluster and option. Okay, on the table using the index name. This is the syntax. Okay, what I can try to do is I can just try to do cluster. Which table I have to cluster? Test table, right? Using index name. So this is the index which I have, right? So I can just do a clustering operation. Clustering operation is, this is simple table. It has done very fast actually. But if you have very big table, then it may take some time and it requires an exclusive lock from the table. Okay. It is like downtime, okay, to do this clustering operation because it will have an exclusive locks on the table if you directly do a clustering. But if you are using the PG repack operation, okay, it is an online operation. Even with the help of PG repack, you can also do a clustering. See, if you see, when I do clustering, when I do select, okay, without order by class, I can just try to give, don't want order by class. So without order by class also, I have my data in proper order right now. It has segregated the data in proper order with the help of clustering operation using this index. Okay, this is how you can have your data in proper order in the physical layer itself with the help of clustering operation. Okay, this will improve your performance, right? So definitely it will improve your performance. Otherwise, you have to use order by class or something like this to fetch your data in proper order. So you have clustering operation. Maybe you can use if you want to store your data in the physical layer itself in proper order with the help of cluster. So this is available in Postgres. I don't think in Oracle it is available. Some kind of storing the table data in proper order in the physical layer itself. So it has to fetch the data from disk and it has to process the sorting and merging or order by class, everything in the memory area, and it has to provide the output to the user, right? So yeah, still we have few more things that we need to discuss, how we can forcefully use the index operation and how we can see if you have an index and if your index is not using properly, how we can identify and how we can use that index to be used in the select query. So these kind of scenarios we'll see. And we also have the partitioning concept. What are the types of partitions available and how we can create the partitions, range partition, list partition, something like this. We can see it tomorrow. Okay. And we'll also see how the partition pruning is happening. Okay. In Postgres. So as discussed, partitioning is something different than Oracle and in other RDBMS in Postgres. So partition is something, a separate child table that we have to create that we'll see tomorrow practically to understand better. And we'll see partition pruning as well. And we'll also see some of the data export and import options, not PG dump and PG import. With the help of copy command few times, you will get a requirement from development team to load some CSV file into your database or to export your table data into CSV format. So what is the best practice that we need to follow in terms of performance? That also we'll see tomorrow. And then we'll also see how we can generate AWR kind of report in Postgres, like similarly like AWR with the help of PG profile extension. So we'll see that as well in tomorrow class, and followed by some of the main important system catalog views for reactive tuning. Like if you want to check any logs, if you want to find out the long running objects, what are the current sessions connected, how many average sessions I have, okay, what is the SQL commands that has been currently running in the database, all those stuff we'll see these all concepts tomorrow. Okay, so that's it I have for today. Probably we can see remaining stuff tomorrow. I will provide the lab manual for each and everything for this performance tuning as well. You can try to practice. So you have any questions so far?
Discussion.
Okay. Sorry, your voice is little low. Can you come again, Sadhan?
Do you have any
Still your voice is breaking.
No. I will pose questions tomorrow.
Okay, sure, yeah.
Thank you.
Okay, then thank you. We'll catch up tomorrow for the remaining stuff.